So if I want to find the volume of this region enclosed by the square root of x and x squared, we would be mirroring this enclosed region on the other side, but we would have all of this empty space, right guys? So I need to figure out a way to get the true volume without including that empty space. So what I want you guys to understand, and hopefully this makes sense. If I just take one cross section, okay, just watch what I do first. What I want you guys to imagine, can you guys turn and look at me? If I were to spin this, one cross section would be some sort of circle, right? But what's different is right now, because of this emptiness, basically there's a hole in the middle. If I took like one slice of this volume, so this is why it's called a washer. I don't know if you guys have ever seen those before, the metal ones, like when you build stuff. That's basically what one little cross section looks like. So basically what I need to figure out is what would be a formula I could use to get all the cross sections and subtract that emptiness on the inside, okay? So this is what you're gonna do. Whenever you guys do these problems, I want you guys to think top function minus bottom function, okay? And this case is gonna be really easy today because all of our functions are gonna be respect to an axis. Starting when we come back from break, it's gonna get a little bit more complicated. So in this case, if we're revolving this around the x-axis, which function is farther away from the x-axis? The square root function or the parabola? Square root function. So what I want you guys to do, and if you guys have iPads, you guys are kind of like at an advantage right now because you guys can do different colors. If you guys are doing this on paper, I would use different colors if you guys can, like pens, because what I want you guys to see is from here to here. Do you guys agree that distance is larger than from here to here? Do you guys see what I did? This green radius and this red radius, this represents the large radius from the top function to the x-axis. This represents the area from the bottom function to the x-axis. So the formula that we're going to use is I'm going to actually find this volume and subtract this volume, because then I'll get the volume in between and get rid of this emptiness, okay? So this is the formula we're going to use. V is equal to, we're doing it with respect to the x-axis, guys, so where would the blue region start? 0. So it'd be the integral from 0 to 1 of pi. Remember, it was pi times our radius squared. So we're going to do big function minus small function, the function that's farther away. Do you guys agree that the square root function is farther away? So that would be your big R. So it would be square root of x squared dx minus the integral from 0 to 1 of the little radius, pi times, what's the little radius function? X squared, and then we have to square it, dx. Now this is a lot of writing, so we can do some simplification. Do you guys notice that they're both integrals from 0 to 1? Okay, and you guys notice that they both have a pi in the formula. So what I could do to combine these into one integral is put the pi on the outside, same bounds from 0 to 1, and it's just going to be the big function squared minus the little radius squared dx. And if I want to clean this up, what is the square root of x squared? X minus what's x squared squared? X to the fourth dx. This would give me the volume of our shape. Okay. So we need a general formula for washer. Okay, now you guys just learned about the disk method. The disk method is different because there was no emptiness inside. That sounds really, really like I'm your counselor. There's a gap, okay? There's stuff missing. that's when you use the washer method. If there's no missing parts, that's when you use the disc method. When we start reviewing for your test, there will be questions that include both, so that way you guys can tell the difference between both methods, okay? So the volume is equal to the integral from A to B of pi times. This is the way that we're going to denote it. The function that's farther away, we're going to call it big R, the big radius, squared dx, minus the integral from A to B of pi times the one that's closer, the smaller radius, squared dx. So does that make sense, guys? Big R and little r. All right, so combining these and simplifying this, the formula is going to be pi times the integral of A to B of big R of x squared minus little r of x squared dx. Please highlight this. Okay, one very, very, very common mistake, and even myself, guys, it's been a while since I've done calc, so I'm kind of like, every lesson I'm doing, I'm like reteaching myself the calculus, and then before I teach it to you guys, because I've never taught this class before. A big common mistake is if you're working too fast, you might do that. This is not the same as taking the big thing and squaring it and subtracting the little thing and squaring it. Does that make sense? So don't do this. No. Now, I'm grading one of your quizzes as we speak, and I'm noticing that some of you guys are doing great with getting the correct answer, but I'm not seeing any integrals on some of you guys' work. You have to write the integral because that's something that they're looking for. Do you guys agree this is calculus? The integral sign is calculus. You have to show that when you guys are showing your work. When we start reviewing for the AP test, I will give you guys like the grading rubric, and you guys can almost like grade yourself. You guys will do an FRQ and then you'll grade yourself, and you guys will see like what they're looking for. And you guys would be surprised, they're actually not looking for that many things. It's really easy to earn points if you guys just show you know some calculus. Okay, does that make sense? Okay, all right, so let's finish this off. Where capital R of x is the radius to the outside of the object, and little r of x is a radius to the inside of the object. What I want you guys to remember is this is like the one closer to your axis, and then this is the one farther from your axis. Okay? All right, so we're only going to do one problem, and then I'll let you guys practice. Okay. Remind me, I also have some good news when we're done with the notes. I just don't want to say it in the video. In case, I don't know who listens to my videos. I don't know how famous I am. I'm just kidding. I probably have, like, nobody watching my videos. It's fine. It's fine. Find the volume if the region enclosed by y is equal to x squared plus 1 and y is equal to 2x plus 1 is rotated about the y-axis. So this is important. So I'm spinning it like this. So this is my region. So if I try to mirror it, what's nice is this is already mirrored on the other side. So I'm going to try to mirror the line as best as I can. So maybe something like that. Okay, so can you guys imagine that all this space right here is empty space? You guys see that? So if I'm spinning this around this axis, it's gonna create some shape that looks like this. It's gonna be circular, the top's gonna be circular. And then it's gonna look something like this. And then this blue represents, like, if I were to turn it and look on the inside, this would be all the empty hollow space. Okay, so let's copy down our formula. V is equal to pi times the integral from A to B of, since we're spinning it around the y-axis, is it going to be r of x or r of y? R of y. So you're going to do big radius, so r of y squared minus little radius squared dy. Okay. So we have to do a couple things. Since we're doing it with respect to y, instead of doing top minus bottom, do you guys agree we're doing right minus left? Okay, so if this is the y-axis, I have to figure out what's big R and what's little r. So if this is the y-axis, guys, which function is farther away from the y-axis? The parabola or the line? The parabola. So this is going to be big R. And then do you guys agree then that the line is going to be little r? Does that make sense? Okay. So then all I'm going to do is I'm going to plug in those functions in for r of y, plug them in for little r of y, I'm done. That's it. Most of these problems are calculated. The hardest part about these is setting them up. Once you have it set up, you're good. That's it. Okay. But the problem is though here, r of y, I have things in terms of x. So what do I need to do first? Solve for x, okay? So if y is equal to 2x plus 1, I'm going to subtract 1 from both sides. Divide both sides by 2. And since for this problem, I would let you guys just plug it into a calculator, I'm okay if you guys just leave it like that. I don't care. For the other function, y is equal to x squared plus 1. Subtract 1 from both sides. Take the square root. Technically, it should be plus or minus, right? But since we're looking at this region right here, do you guys see how this is on the positive side? So I'm going to take the positive square root. So remember, the parabola was big R. So this is going to be big R of y. And this, so that's going to be little r of y. So for my integral, the volume is going to equal pi times the integral of, since I'm doing it with respect to y, I need to do my bounds in terms of y. So where does this integral begin on the y-axis? 1. Good. 1 to 5 times big R of y. So the square root of y minus 1 squared minus little r. So y minus 1 all over 2 squared dy.